Hey guys, welcome to this video. I talk about the thermal expansion. This is a new topic. We are going to see various uh, subtopics related to the expansion. That is the thermal expansion of solids, liquids, and the other. We are going to see them in other lectures. So let's start today with the first one, that is the concept of thermal energy. So thermal energy or heat energy is the form of energy that causes the vibration of the particles of a substance. Now, the more the vibration, the more the energy is obtained or contained. Now, so when you talk about this thermal energy, you mean the energy that is resulted by the vibration of the particles. Now, the changes in the amount of heat energy contained in the substance is what causes the changes in the temperature of a substance. Now, what is temperature? Temperature basically is the degree of hotness or coldness of a body. The SI unit of heat is this joule because it's energy. So SI unit of heat energy is joule. Now, the amount of heat content depends on the such factors such as the first one is the mass of the body, the second one is the specific heat capacity, and the last one the change in the temperature, and it can be mathematically shown as heat quantity equals to mass times specific heat capacity times this change in temperature. Moving on, let's see the thermal expansion of solids. When a solid is heated, one or more of the following may occur. Now, these are just of the few occasions that can be resulted to the heating of the solid. The first one is that its temperature may rise. When a solid is heated, its temperature rises. The second one is that its state may change, whether it can be that it melts, and the third one is that it may expand. Now, the expansion of solids is the increase in the dimensions of the solid when heated. So, when a solid is heated, its dimensions are expanding because of that the input of heat. Now, the contraction of solids is what we call the decrease in the dimensions of the solid when it is cooled. So, in solids, these uh, two occasions occur whereby when it's heated, the solid expands, and when it is cooled, the solid contracts. Now, cooling is simply the process of removing this heat from the substance. Let's see the coefficient of linear expansion or linear expansivity. The amount by which the linear dimension of a given solid expands depends on such factors. That the first one is that the length of the solid, whereby the here we're talking about the dimension or the longness of a solid. So the longness of the solid will show the amount by which there is a linear expansivity of that solid. The second one is that the temperature at which the solid is heated, and the last one is the nature of the solid. So the nature of the solid, we are talking about what makes up that solid, whether it's a kind of a certain metal or a non-metal. Now, the coefficient of linear expansivity, this is the fractional increase in the length of the solids per original length per degree rise in the temperature. So, when you ask about the coefficient of linear expansivity, we see that when there is a fractional increase in that length of a solid, uh, per a given original length of that solid and per a given degree of rise in temperature. is where we're going to get the linear expansivity of a given substance. The application of expansion of solids in daily life. Here, just a few of the applications of expansions of solid in real life. The first one is that while laying the railway tracks, a small gap is left between the successive lengths of rails. Why is it left like that? Because in order to allow expansion during a hot day. So basically, this is the expansion of solid is used in the making of railways. There's a second one is that the iron tile is to be put on a wheel. The wheel is first heated until its diameter becomes more than that of a wheel, and then is slipped over the wheel. So also it is used in the making of these vehicles wheels. So basically, when the wheels are to be put to the iron tie, the wheel is first heated until its diameter becomes more than that of the wheel. Then later on is slipped over the wheel. Then when it cools, it will contract and fits to that wheel. So that's all for this lecture. I hope it's clear. I'll talk more on the expansion of liquids in our next lectures. Thank you.